Good evening, everyone. Welcome back to 30 days free short-term training program from Python to AI. So I hope everyone is doing well and you guys are ready for understanding a new topic today. So guys, before getting started for the day, we'll quickly revise what we have understood in the last class, right? So in the last class, we have discussed NumPy module, right? We discussed NumPy module. So NumPy stands for numerical Python, and for what purpose we generally use NumPy? We use NumPy in order to do some sort of numerical calculations. In order to perform any numerical calculations, we are supposed to use NumPy module, and this was developed in the year 2005, and it was developed in both C and Python languages. And what is a command that we use to install NumPy? Pip install NumPy. Right? This is the command that we are supposed to use in order to use NumPy module. Right. Then what else was being discussed? We discussed that NumPy that is present in Python is especially used to create arrays, n-dimensional arrays, can be created using NumPy module, NumPy library. What is a module? Module is nothing but it's a collection of variables, functions, and classes. So post installing NumPy into our machine, local machine, we have to import the module. Import NumPy is the command, right? Import NumPy is the command. What is the use of importing? As we discussed, a module is collection of variables, functions, and classes. Whatever is part of NumPy module, in order to access them, I have to import them initially. Only after importing a particular module into the sessions memory, we can access any kind of object, variable, function, or class inside that particular module. If you don't import any package, we cannot access these objects. I hope it's clear. So for that purpose, we generally import any module post installing it. Right. Then we have understood how can we create n-dimensional arrays using NumPy functions like array function, then zeros function, arrange function, ones function, full function, then what else? Identity function, reshape function. All of these functions are used to create arrays. What is an array? Array is again it's a object in Python, but it's not an inbuilt type like list, tuple, other data types available in Python. It's not an inbuilt type. We are supposed to create arrays only using NumPy module in Python. Okay, so array is similar to a list where all the elements are present inside square braces, all the values are present inside square braces, but the values of the elements of an array will be space separated, not comma separated. If you take a list, the values or elements of a list will be comma separated. Am I right? Yes. But if you take an array, the elements or values of an array will be space separated. Okay, so that makes an array, and arrays generally hold similar data type elements. It also supports, different data type elements to be part of an array, but internally it considers all these elements of one type only. Right? Then we understood indexing, the same concept. Indexing is nothing but accessing one value or one element of a array of an object. Then slicing, where the slicing takes the syntax of start colon stop colon step size. Then what else? Advanced indexing was also being discussed as part of these arrays topic. And operators, we discussed arithmetic operators, on these arrays, how arithmetic operators works on arrays. Because in general, if you take a list and perform arithmetic operation, 1 comma 2 plus 1 comma 2, this is a list, and this is also a list. When you try to when you try to add to list, it does not, the output will not be 2 comma 4. The output will be 1 2 comma 1 2. This is called as concatenation. Whereas if you take two arrays, 1 2 plus 1 2, the output will be not 1 comma 2 1 comma 2. The output will be 2 4. The values get added, right? So these are the changes or the differences between list and arrays. All the differences we have understood. Okay, and in general, arrays, computationally they execute very fast compared to list, right? So NumPy module was being discussed, and I hope everyone have completed the hands-on with respect to NumPy module. Right. Now today, it's starting of the week, and I'm here to teach a new concept, Pandas, a very important module in Python. Okay, after NumPy, a very important module, a library, because Pandas is used for data manipulation. In order to manipulate the data that we have, we are supposed to use Pandas functions, right? So Pandas is an open source. It's an open source library module, and it is used for data manipulation. And it is also an analysis tool where we can perform analysis using the functions that are present inside Pandas. The word Pandas was derived from panel data. So this PAN represents panel and DA represents data. What is this panel data? We'll discuss. Okay, but panel data, from this word panel data, Pandas was being derived. Right? So this was developed in the year 2008. Okay, NumPy was developed in the year 2005, and Pandas was developed in the year 2008. Like how NumPy was developed in both C and Python languages, in the same way, Pandas is also developed in both C and Python languages. And the syntax for installing Pandas is pip install Pandas. By default, this syntax will be used for installing any module, any library This command will be used, pip install module name. Okay, and what is the best practice that I have asked you guys to work on? Whenever you going to install a new module or library, you are supposed to visit pypy.org, pypy repository. Okay, so when you visit pypy.org, you can get the command for that respective module, so that there will not be any kind of errors you'll encounter. Why? What is the main reason for that? Python is case sensitive. Python is case sensitive. So, are you sure pandas is in proper keys, or pandas is in lower keys, or pandas is in upper case? Are we aware of it? No. Then how can you use this command, blindly? That is the first question that we have in the mind. So, as a good practice, we should always visit pypy.org before installing a module, a library. From where you can get the command, copy the command, and either if you are using any kind of ID, say IDE, okay, in the IDE itself you can execute this command. But recently I have got a question from you guys asking for, can we execute this command in IDLE, Python IDLE? The answer is no. You cannot execute these commands in IDLE, guys. No, it's not possible. Right? This is a command, and IDLE expects only for you know Python script, Python language. You are supposed to run only Python code in IDLE. How can you execute these commands? So it's not possible of executing these commands in IDLE. Then what should I do, Akhil, if I install IDLE? So suppose assume that I have installed only IDLE. I don't have any other, IDE. Even I don't have Anaconda Navigator, say what Visual Studio, nothing. I just installed IDLE. What should I do? If this is the case, you cannot directly execute this command pip install module name in IDLE. It will throw you an error. Okay, what you are supposed to do is open command prompt. Open command prompt and get the location from where you have installed Python. Get the Python location in your system, change the location in the command prompt to this location, then run this command so that the module will be installed in this folder. Then you go back to IDLE and import numpy. It will execute, or import that particular module which you have installed. This is the process, right? If you are not using IDLE, if you are using any IDE, integrated development environment, okay, like Spider, Jupyter, Visual Studio, PyCharm, Google Colab, whatever it might be, guys, you can directly execute. Okay, you can directly execute in the console, or say in the cells, wherever it might be. You execute, it will install the module. Post installing the module, you are supposed to restart the kernel. Kernel should be restarted, then you can continue. So this will be the process for any module that we are going to install in future, right? So the command for you know installing pandas module is pip install pandas in lowercase. Pip install pandas in lowercase, right? So let me remove all this. Done. So this is the first part. If you are using any IDE, by default NumPy and Pandas will be installed when you are installing that particular IDE or software. What if you are using IDLE, Python IDLE? No module will be installed. You are supposed to install each and every module. Right. Now, assume that we have installed Pandas. Okay, I already have it in my system, but let me show it to you. I'm copying the command and I'm pasting in the console and I'll click on enter. So you see it is under execution. It is under execution. I'll get a successful message. I'll get a requirement already satisfied message because I already have it in my system. And this is my location where I have Pandas. Okay, in my C drive under site packages, I have Pandas and this is the version of it 1.4.4. Okay, so I need not worry about the installation of Pandas. I'm done. So let me proceed. What is the main purpose of learning Pandas library? If that is the question, in Pandas, there are three types of data structures in which the data can be stored. Okay, there are three different types of data structures. The first one is series. Okay, in which it is a one-dimensional object similar to a one-dimensional object like uh, a list, a tuple, array. These are one-dimensional objects, right? Yes. Then data frame, which is a two-dimensional object. Okay, in simple format, it's nothing but it's a table which contains rows and columns. Okay, if you open Excel sheet, you will have rows and columns, right? So it is nothing but data frame. It's a two-dimensional object. Then comes the third data structure, panel. Okay, which is used to build multi-dimensional objects. Okay, in order to store data in a multi-dimensional object, panel data structure will be used. But we generally ignore this one because we not use it majorly. Our main focus will be series and data frame. Out of series and data frame, again data frame we'll use more because in general the data is in structured format, right? So we generally go and use data frames more compared to series, right? But let us start with series, then we'll understand data frame as well, right? So what is a series? Series is a one dimensional labeled array capable of storing homogeneous data of any type. So it's a one-dimensional object which is labeled. Labeled in the sense we can give a name to this one-dimensional object, right? And it can contain homogeneous data, the same type. And Panda series is nothing but the series that we are talking is nothing but it is referring to a column. In an Excel sheet, if you take a one column, this is nothing but series, a one-dimensional object. That's it. It contains only multiple rows and the number of columns are fixed one. A single column is representing series and series values are mutable. What is the meaning of mutable, friends? Mutable means it can be editable, they are changeable, right? What is the syntax for series? Series is an in function coming from pandas. So pandas dot series of, so since it is a function, we use parenthesis. Yes, we use parenthesis, and within the parenthesis we have to specify the object. Object is nothing but the data. Okay, what object you are going to convert into series. Then index, by default, series objects have, they are indexed, and we know in Python by default indexing starts from 0 till infinity, depending on the number of values that the series object contain, and the data type of the elements, the values present in the series. So this is the syntax for series function coming from pandas. We'll take a small example and let us see how can we create a series object. And there are multiple approaches to create series object. We'll see one by one. Right. So first thing is, make sure that you have installed pandas. Okay, I have installed it. Now I'm importing it. Okay, so import pandas will be the command. You have to import the pandas, and like how we have imported numpy, in the same way we have to import pandas into the sessions memory. Okay, so when you import pandas, whatever is present inside pandas will be imported to the memory. And this pandas, I'm giving an alias name as PD. Okay, I'm giving an alias name as PD. Akhil, what is the benefit of giving an alias name? Simple, my friend. In order to use, or in order to use any function coming from pandas, every time I have to refer pandas dot function name, pandas dot function name, so on. So every time I have to keep it as pandas, pandas, pandas. It's better if I give a shortcut so that I can use that shortcut, right? This would be better. So I'm giving an alias name to my module pandas. What is the shortcut I'm giving over here? It is PD. Why PD? Why not KD? Again, you may have the question, right? Again, that's up to you guys. You can also give your name. Whatever you are willing to give, you can pass it, or you can give an alias name for pandas. But make sure in the next lines of code, you have to refer to that name every time. But PD is actually referring to standard. Okay, if someone is going through your code, Python script, and if you are using pandas as PD, immediately they can recognize that PD is nothing but pandas. So it is universal recognized shortcut. Like how we give an alias name for numpy as np, in the same way we are giving PD as a shortcut name for pandas. Right, now it's clear. Let us proceed. What am I doing in line number? Okay, let me execute line number 397. I'm importing pandas as PD. Job done. Now, what am I doing in line number 400? What am I doing? What is that? It's a list object that I have defined. I'm defining a list object, and all the elements that are present in the list are integers. Right? Yes. So the name of the list is list 1, the type is list, size is 6, and the elements are 10 till 60. Values are 10 till 60. Now this list I am converting to a series object. How? Using series function present inside pandas. PD dot series of object. The series, the syntax is series of object. What is the object that I am trying to convert here? It is a list. So when I execute line number 401, S holds a series. S becomes a series. See, S is a series and the size is 6 comma. As we discussed, series is nothing but a column. It's a column. And whatever you are seeing, this 6 is representing number of rows. So these 6 values are stored in this way: 10, 20, 30, 40, 50, 60. One column, this is one column, and 6 rows. See, and as we are aware that lists are indexed, by default it starts from 0, 1, 2, 3, 4, 5, right? So by default indexing starts from 0. And Akhil, I did not specify the D type. Even if you don't specify the D type, it considers all the elements as integers. Okay, so let me show it to you. When you try to open this, you'll understand. This represents the index and these are your values. Don't get confused. The first, this is not a column. By default indexing, Python supports index for all the values, and series is nothing but one column. So this is the one column, and I have converted a list of 6 elements to a series. So obviously I'll get 6 rows. 1, 2, 3, 4, 5, 6. Okay, so let me print that series to console using print function. Along with the series, I also want the type of S. So it have to return as it is a series. This is nothing but series. Okay, S. And if you see, the data type is integer. Okay, and the type says series. Pandas.core.series.series. So this is again referring to classes topic. Let us not go inside of that. So it's a series object. Right. Now it's time for you. What are we doing in line number 404? What is it? What are we doing in line number 404? We are creating a list again with same 6 elements. All of the elements are integers. Where are we storing it? In list 2. Good. Stored. Then what makes the difference between line number 405 and line number 401? What is the difference between 401 and 405? Yes, we have explicitly defined the data type D type as float. If you observe, we can give the value for D type as per the syntax. So I don't want integers. I want to store float values inside this series object. So a list is being converted to series and the data type that is going to stored is float, that is nothing but decimal values, and it will be stored in yes. So let me show you the output. If you see, all the values are floating numbers: 1.0, 2.0, 3.0, so on 6.0, and the type is series. Good. Yeah. Yes. Okay, guys, for better understanding, I should have told you in the last session itself. Okay, so what you'll do is, from today, starting from today, I request all of you to go through the documentations. See, when I just hover my mouse on the function, it's giving a documentation if you observe, right? So this documentation is available in the official sites of say Pandas, NumPy, whatever the module might be, the library. You have to visit the official site and go through this documentation. Okay, so this is an advantage of Spider. It just gives you the crisp documentation of any function, but in order to get the complete documentation of any function, or say any say package, library, or whatever it might be, you better go through the official documentation available over the net, over the internet, right? I'll show you at the last. Just I'll tell you why it is taking the d type as integer. If not, you go through the help pane. Okay, in the help pane, you give the required uh, object for which you are going to search the documentation. It is series, right? So in series, where is d type? Ah, see, if you see here, data type for the output series, what should be the data type? If not specified, this will be inferred from the data. Since I did not specify, depending on the values of the data, it is taking the data type. Is it clear? So it's better if you go through the documentation of the functions, you will understand each and every line of code in depth. Okay, so just make a habit of going through the documentation starting from today. Right. Now let me create a list, and this time I had it like I had an integer, I had string, I had floating value, and this is also an integer. Let me create it. Done. Now this list I am converting to series object. Will it execute? Yes, it will execute. It will execute. Then let me print it. You see, what is a D type? Did I specify? No, I did not specify the D type. It's taking as object, which is nothing but 10 is no more considered as an integer. 10 is an object, nothing but text. 34.56 it's belonging to D type object. Okay, so depending on the data, it is inferring the D type. Done. Now let me take one more list, and I'm printing the list to the console using print function. Okay, so what makes the difference between the previous example and now is I'm going to define my index. Akhil, is that possible to define the index? Yes, then. Yes, we can define our own index. By default, if you don't define, it starts from 0, 0, 1, 2, 3. Okay, what if I want to define my own index? Just specify. My index should be like STNO, okay, student number, then name, marks, designation. So this is my index. Let me execute. Let me print it. You see, let me also open this. By default, it takes 0, 1, 2, 3. But I don't want 0, 1, 2, 3 no more. I want my own index, so I have to define it. Okay, so this represents my number, student number, then my name, marks, and designation. Depending on, to get a clear understanding regarding these values, we just took these index values. So it means you can define your own index. Okay, we can come up with our D type, and we can define our object. So depending on these three, we can create our own series. Series is nothing but a one-dimensional object which is referring to a singular column, okay, with multiple rows. The value that you see is representing rows, right? So far I am using only, what list. Let me use tuple. Can we, or is it possible to define or come up with a series object using tuple? Yes, yes, it is possible because tuples are also indexed. Okay, since they are indexed, I'll use a tuple object and convert into a series. Yes, so let me execute it. The same syntax pd dot series. Inside series, I have to specify the object. Let me print to the console. So by default, indexing starts from 0 and the d type is integer, depending on the values of the data. Okay. Now the question is it possible to create a series object using set? I want you guys to answer in the chat. Is it possible to create a series object using a set object? Yes or no? Hmm. Okay, I see. Okay. Why yes, why no? The question is why yes, yes, we are good. It is not indexed. If it is not indexed, okay, first of all, it is not ordered, right? So if it is not indexed, how can you convert a set object into series object? Because series supports, indexing. If there is no index, how a set object can be converted to a series object? So it will throw you an error. As an experiment, I want you guys to try it, pause the session, right? Yes. Now let us create a series object using dictionary. Is that possible? Yes, because dictionaries are indexed. Oh my god, how come? If you remember, a dictionary is nothing but a key value pair, right? Values are indexed via keys. Okay, then I can use this dictionary for creating a series object. Yes, I have created a, where is D1, D1, D1. Yep. So here is D1, it's a dict object, nothing but dictionary, and the size is 4. And I'm printing this D1 to the console using print function. Using series function from PD, I'm going to convert dictionary into series. What might be the output? Simple. Since the values of dictionary are indexed via keys, the keys of the dictionary will be the indexes in the series and the values will be the elements in the series. I hope it is making sense. So this will be the output. The keys sub 1, sub 2, sub 3, sub 4, subject 1, subject 2, subject 3, subject 4 will be the indexes, whereas the values will be the elements of series. Let me open S. See, I hope it's clear. Now the next experiment is creating a series using an array. Is that possible? Yes, it is possible. For that, I am importing pandas and numpy because, as we discussed in the last class, an array object can be created only using numpy module. I am taking a list of integers and using numpy module, using array function from numpy module, I am converting this list to an array and I'm storing it in data underscore array. So this is array. Okay, this is an array, numpy object array. Right. Now this array object I'm converting into series because arrays also support indexing, so it does not throw any kind of error. It will execute. See, is it clear? Series. Series is a one-dimensional object which is representing a single column in our Excel sheet. Okay. The series values, Panda series object values are mutable. You can change them. See, I'm converting a list to an array object using array function present in NumPy. Where am I storing it? In data underscore array. So data underscore array is an array, and if you want to have a look, this is the array 10 till 50. And we know that array objects are indexed, right? We discussed indexing, slicing on arrays, right? So as it is indexing, as if they are indexed, we can convert the array into series. PD dot series of data underscore array, which is nothing but an array object. I'll execute this and it is stored in series from array. I'm printing it. Clear? Yes. Now let us understand the data frame, the second important data structure of pandas. Series is a one-dimensional data structure, right? It's a one-dimensional object. Whereas a data frame is a two-dimensional object where the data is stored in a tabular format. Okay, so the data will be stored in a tabular format. What are the horizontal ones called? These are called as rows. What are the vertical ones called? These are called as columns. The data will be stored in the form of table. A table is a collection of rows and columns. So in simple, data frame consists of rows and columns. Right? So these columns that are part of data frame can have similar data type elements or different data type elements. I mean, if the first column contains integers, second column values might be, float or integers. Anything is accepted. Like how series object is mutable, in the same way, data frames are also mutable. Okay, what is the syntax for data frame is the same, but additionally you will have columns. These columns take the names of the columns present in the data frame. Series, as part of syntax for series, we have object, index and d type, right? Additionally, we see columns, right? So we'll discuss, that is what we'll discuss. Yes, in short, we can say data frame is a collection of series. Yes, because this is series, this is series, this is series, I can create a data frame using series, multiple series. Yes. Valid question? Yes. The answer is yes. So again, we had n number of approaches to create a data frame object. We'll do one by one. You know, whatever our friends have raised the questions. For all your questions, I have the answers in the coming lines of code. Okay, pay attention. For that, I have to import pandas initially. I'm importing pandas as PD. Now, first of all, I'm taking a list and I'm creating a data frame object using a list object. Is that possible? Yes. For better understanding, let me remove everything present in the memory. Let me restart the kernel so that you'll understand well. Right. So I'm creating a list of 4 integers, and this list I'm converting to a data frame using pd.dataframe. Be careful, guys. Data frame that is present here, I mean, as a function inside pandas, it is not only D is in uppercase, F is also in uppercase. D and F of data frame, both of them are in uppercase. Okay, so when you try to change the case, for example, assume you mistakenly you have kept in this way. This no more will be a function. Why? Python is case sensitive. Okay, so you have to use the same case as is. Don't change the case, it will throw you error. Okay, as an experiment, change the case and execute, you will get an error. Right. So I'm converting the list into a data frame and I'm storing in uh, df. Okay, let me execute from the starting. I did not import pandas. Now the list, then the data frame. Done. So Akhil, on what basis you tell this is a data frame? We discussed data frame is a two-dimensional object, right? You go and observe the size of data frame, df. It is 4 by 1. What does 4 by 1 represent? 4 rows, 1 column. 4 rows, 1 column. But do you observe the similar size for series? No. You will observe only one value for series. That makes the difference, guys. Okay. So this is a data frame. Right. Let me take a nested list and create a data frame. Is that possible? Yes. What might be the output? Go for a wild guess. This is a nested list of two lists inside a list. And now I'm going to convert this nested list into data frame. What might be the output? The output will be 2 by 4. Don't assume that each list will be taken as a column. Each list will be considered as a row as part of nested list. So when I open it, this is the first nested list and this is the second nested list. That's where the problem starts. Okay, so it is two rows and 4 columns. In the same way, let me take 4 nested lists. What will be the output here, guys? If I try to convert this into a data frame object. But additionally, I'm also passing index columns also, the values for the columns also. Why? Because by default, indexing starts from 0. I don't want to start my index from 0. I want to start from 1. So the values for the index are 1, 2, 3, 4. And the column names, is it giving any column names? By default, it again starts from 0 only for the column names. as part of indexing. But I don't want these as my column names. I'll pass values for my columns also. So they are roll number and name. Let me execute all these lines together. Okay, done. Now let me print this data frame to the console. See, four nested lists, so four rows. In each nested list, I have two values, so two columns, and index by default we started with 1 2 3 4, and these are the index values. And the column names, I don't want the index values, I kept it as roll number and name, roll number and name. Clear? Now it's fine. I do the same with tuple object. Is that possible? Yes, because list and tuple are almost similar, but they vary in only one aspect, that is mutability, right? So that is not affecting the case over here. So I'll create a tuple object where I have five. It's a nested tuple with five tuples, and I want to start my index with one, and the column name should take as name and age. Let me print df to the console. See, this is a data frame. 5 rows, 2 columns, 5 comma 2, a two-dimensional object. Right. Now, in the same way, I'll do the same with respect to by taking a data frame. By taking a dictionary, let me create a data frame. Okay. How many key value pairs do we have? I have three key value pairs. One, two, three. Okay. The first key value pair represent names and the names of the people, and the subjects, and finally their ages, corresponding ages. So I'm defining my dictionary, and this dictionary I'm going to pass inside a data frame so that I get a data frame from dictionary. But what will be the output? What will be the output in case of line number 475? Will names, subjects, and ages be part of indexes similar to what happened in series, or what might be the output? The output will be names, subjects, ages by default takes as column names. Okay, so will it be 3 by 4? Come on guys, will it be 3 by 4 or 4 by 3? Ah, it will be 4 by 3. See, it will not be similar to series. In series, keys will be nothing but the indexes. Whereas in dictionary, when you are trying to use a dictionary to convert into a data frame, the keys will be stored in column names. No more it will be part of indexes. So the keys will be as column names and the values will be part of the values. So by default, again, indexing will be from 0 till starts from 0. If you don't want to have it from 0, you have to define your own indexes using index, argument, parameter. Right. So earlier there is a question, right? Can we create a data frame using series? Yes. What am I doing? I'm taking a series, I'm taking a list, and this list I am converting to a series object, and this series object I am converting to data frame. So what will be the output? 4 comma 1. Let me print it to the console. So 4 comma 1 will be the size of the data frame. Okay, let me give it for you. I'm taking a dictionary, and this dictionary I'm converting into a series. So can you tell me what will be the size of S data, a series object? What will be the size of S data, a series object, when we try to create a series using dictionary? 2 comma 4. Is it correct? Will it be 2 comma 4, guys? No, no, no. Think. A series is a one-dimensional object, and I see all of you, posting 2 dimensions. Think what will be the output? What will be the output in this case? No, still, just give a try, guys. Series object is a one-dimensional object, and it will be what? What will be the size of S data before I reveal? Okay, anyways, it got revealed. The size is 2. Just now we discussed, right? The size is 2. Why? Because internal marks, external marks are nothing but two keys present in the dictionary will take the place of indexes, and this entire list will be stored in row 1, and the second entire list will be stored in row 2. See. Pay attention. Okay, right. Now let me print this series to the console using print function. So this is the series where int marks, ext marks are representing index, and this is the value. This is the value. Don't get confused. Now this S data, which is a series object, let me convert into a data frame. Now it's your turn. What will be the output if I convert a series object to data frame? Will it execute? Yes, because in the previous example, the series object got converted to data frame. In the same way, what will be the output here? This is my series object, and I am going to convert this to my data frame. What will be the output? 3 comma 4, not exactly. Think. Okay, okay, yes. Now if you see what happened, let me show it to you here. It's 2 comma 1. A 4, initially, this is just the logic that you have to capture. See, a series of 4 comma got converted to data frame. What is the size? 4 comma 1. In the same way, a series of 2 comma is being converted to data frame. What will be the output? 2 comma 1. I'll get only one column, guys. Okay, one column, and where I see my values, and the index doesn't change because this is by default a series, and that series object we are converting to data frame. I did not define my index also when I'm converting to data frame. So this does not get converted. It will be as is. Don't get confused. Am I defining here? Did I explicitly define index? No, right? So how can you expect that it will change the index? Clear? So the index will be maintained. It just changes the shape because it's a two-dimensional object. Data frame is a two-dimensional object. Series is a one-dimensional object. Right. Now using an ND array object, I am taking a array. Okay. For that I'm importing numpy. Okay. I have took a nested list and I'm creating an array object. So this will be, what will be the size of A? I want you guys to answer. What will be the size of A? NP dot array of L1, which is a nested list. Give a try, guys. It will be, let me show it to you, 3 by 2. Okay, it will be 3 by 2. And this 3 by 2, which is an array, I am converting into a data frame. So the same will be converted and let me print it to the console. See, as is 3 by 2. Yes. Now taking this this array, let me add columns. A is an array, right? So let me add column names as int marks, ext marks, okay, and convert this as a data frame. So this A, I took it as is array, but this array I'm going to convert into data frame. In this data frame, I want the column names as internal marks, external marks, and storing it to data frame, df. The same output, but additionally, instead of having 0 and 1 as the column name, I'll have int marks, ext marks. That's it. I'm just defining my column names. Right. So we have understood all the possible ways of creating data frame using different objects. What if your data is stored in a CSV file? Different files. Yes, all the file formats, whatever might be the file format the data is residing in, we have the functions in Pandas. Assume that the data is present inside a CSV file. Okay, so we have a function read underscore CSV to read the data from an offline CSV file. Okay, so what are we supposed to pass inside a read underscore CSV file function is, this is nothing but the path of your file, CSV file. Okay, make sure you give the entire path of the CSV file, and the R that is given in front of the path talks about, or it represents that to consider this entire string in the raw format. We'll discuss this again when we actually start working on use cases. But in general, in real world, some companies still store their data in offline files like Excel file, say JSON files, CSV files, whatever it might be. So in order to access such kind of data, okay, in order to read the data that is present in offline files like CSV, Excel, we have all the functions present in Pandas. Okay, so if it is a CSV file, the function is read underscore CSV. Inside read underscore CSV function, we are supposed to pass the location, nothing but the file location where the file is present in the local machine. We are supposed to pass the file location, and in front of the location, I just kept it as R, right? Small r. Even though if you remove this R, for some people it may execute. For me, it's not executing because I'll get an error when I execute this line. The reason is, if you observe carefully, in the path I have backslash as the character, backslash users, backslash user, backslash downloads. So there are some special characters in Python, and when you don't use R in front of this string, nothing but the file path, the PVM, the interpreter, gets confused whether to consider it as a special character or a normal path. Okay, so for that reason, we have to specify small r, that this small r represents to consider the entire string, whatever we have specified in the string, in the raw format only. Okay, it considers this path as is. Then it reads, it goes into this file. Okay, this is my file name, dataframe underscore group by .csv is my file name. It goes into this file and reads the data and stores in data variable. So let me execute and show you the output. See, this is my data. The same data I have it in my local machine. Let me show it to you. See. It's taking time. Right. Okay, let it be. It's taking time. The same data I have it in a CSV file. Okay, I have loaded the offline CSV file into a data frame. It's a data frame, and if you observe, in total I have 10 rows and 5 columns. What are the columns that I have? ID, name, age, city, experience. Is that loaded? Still taking time. Okay, I'll show it at the end. So this is my data frame, and how did I get, or how did the load data got read? Using read underscore CSV function present in Pandas. So I can even print the data to the console using print function because the data is very small. Okay, so this is the data, and what am I doing is, so from here onwards, we'll have only the functions that are present on inside the pandas, and these functions can be used only on a data frame object. So data is nothing but a data frame object. So what I'm doing is, I'm using set underscore index function in order to reset my index. So by default, the index starts from 0, right? I don't want to have this index starting from 0. I want to use the values of ID column and replace or reset these values of index with ID column values. So I am going to use set underscore index function, and this will set the index values. See, done. Let me open now. So no more I have ID column in my data. The ID column became my index now. If we observe, in the previous case it is 10 comma 5. Now it became 10 comma 4. Okay. So this is good. Then comes head function. Head function is used to return the top records. By default, it returns 5 records. If I don't mention the number, by default it returns 5, the top 5 records. But if you keep it as a number, so the top 3 records will be returned. Let me expand this. Yes, I hope it is clear now. In the same way, tail function gives you the bottom records, like how head function by default returns top 5 records. In the same way, tail function returns the bottom 5 records. And if you don't want 5 records by default, you have to specify what is the number of records that you want to want. Okay, and I want 3 records in my case, so I have specified 3. So if you see 8, 9, 10, the bottom 3 records are returned. Okay, so next to tail we have shape attribute returns the size of the data frame. Okay, so this will return as nothing but 10 comma 4, nothing but the size. Akhil, what is the use of this shape? That's what we have discussed, right? So it returns as the shape of the data frame. Anyways, I have it over here, right, Akhil? Why again? Why should I again go and look after the shape of the data frame? My friend, this is only a added advantage, a unique advantage that we get from Spider. But if you open any, or if you are working on any other IDE like say Jupyter Collab, Visual Studio, or Google Colab, whatever it might be, you will not have such kind of feature. So if you want to get the size of your data, the only possible way is shape. Data.shape will return us the size of the data frame. Then describe. Describe function returns us the entire descriptive statistics of the data. So what is this descriptive statistics? It's nothing but it returns as the count, mean, average, nothing but mean is nothing but average, STD, standard deviation, then minimum value present in the column, maximum value present in the column, then 25th percentile, 50th percentile, 75th percentile of the values in numerical columns only. Akhil, in the data frame there are 4 columns, but I see only the output for 2 columns. The reason is out of the 4 columns, only 2 columns are numeric. Rest of the 2 columns, name and city, are non-numeric. And describe function does not work on non-numeric columns. Why? What is the reason, Akhil? So before you ask me the question, just think of how can we calculate average for a non-numeric column name. Impossible, right? So describe function will not work for non-numeric columns, categorical columns. It works only for numeric columns. Right. Then next to describe, we have drop function. So drop function is uh, you know used for dropping or removing any column from the data frame. So data dot drop, and what is the column that I am going to drop? I have to specify using columns parameter present in drop function. Okay, so this will drop city column from the data and the output will be stored in df. So df is again a data frame, but the size is 10 comma 3. Original data shape is 10 comma 4. Since I have removed city, the output will be 10 comma 3. Right. What makes the difference between line number 525 and 527? Again, I'm using the same drop function, but am I using columns? No, right? If you don't specify columns explicitly, you have to mention axis. Axis represents either rows or columns. Axis is equal to 0 represents rows. Axis is equal to 1 represent columns. So either you specify columns or either you specify axis, both are same. So I'm doing the same thing, but this time I'm storing the output in df1. So df and df1 we should have the same shape. df is 10 comma 3, df1 is also 10 comma 3. Clear? Right. Then what is the difference again? Why are we using again the drop function? In line number 525 and 527, I am storing the output to a variable, right? In line number 525, I am storing the output to df. In line number 527, I am storing the output to df1. Whereas if you observe in line number 529, am I storing the output to any variable? No, right? So what are we going to do over here? I'm dropping city. Okay, I'm specifying the axis is equal to 1. That is, you know, column city should be dropped, and I'm additionally specifying in place is equals to true. What is this in place is equals to true means? In place is equals to true represents that we have to drop city column from data in the same variable, in the same object. It means if you observe, is city present in data? Yes, city is still in data. How come, Akhil? Friends, here we dropped city from data and we are storing the output to df. That doesn't mean city is permanently dropped from data. City is present, city column is present in data. Okay, what if you want to, permanently remove city from the original object? Then go and perform in place operation. For performing in place operation, you have to specify in place is equals to true. Okay, observe carefully. Now the size is 10 comma 4. I'll execute line number 529. It becomes 10 comma 3. Done. The shape is, the size is 10 comma 3. I no more see city column in data. This is nothing but in place operation. Okay. Then the next function that we have is sort underscore values. So sort underscore values is a function that can be used on data frames, which is performing sorting. Okay, based on the age column values, it sorts the data. Okay, so by default, it is giving me ascending order, age, ascending from 40 till 46. Okay, so if you observe the values, the records got sorted, okay, based on age values, and it is in sorting, ascending order. I want it in descending order. Specify ascending is equals to false. This is a parameter available inside sort underscore values. So specify ascending is equal to false, then you'll get the output in descending order, 46 to 40. Right? The last topic with respect to, you know, uh, pandas, that is LOC and ILOC. We'll discuss this and we'll wind up the session. Okay, so LOC and ILOC are two important attributes that can be performed on, data frames. Okay, what is LOC? What is ILOC? LOC represents label based indexing. ILOC represents integer position based indexing. Okay, so LOC allows us to select columns. For example, this is our data frame. Okay, and as part of this data frame, if you want to get only a subset, or depending, you want a requirement, you don't want the entire data frame. Okay, then you can go and work, you can do it using LOC or ILOC. But before understanding, before working with respect to LOC and ILOC, we have to understand what does LOC and ILOC means, right? How they differ, right? So LOC allows you to select columns by their name labels, by their column names. Whereas ILOC allows you to select rows and columns by their index values. You need not specify the column names with respect to ILOC. Whereas with respect to LOC, you have to specify the columns with their column names. And in LOC attribute, both start and stop indices are included. So whatever you are specifying with respect to start and stop, both will be included. Whereas in ILOC, no. Only the start index will be included and the stop index is excluded. So for better understanding, this is again like indexing only, guys. Okay, but on data frames. So far, we have understood indexing concept on slicing concepts on one-dimensional objects, list, tuple, arrays. Okay, so all these strings, on all these objects, we have understood the concepts of indexing and slicing. But this is a two-dimensional object, and we in general work with data frames only. Okay, so I have created a data frame of size 3. Okay, this is 4 comma 3. Okay, 3 columns, 4 rows. This is nothing but a dictionary. So in dictionary, if you remember, the keys will be column names. So 3 column names, and each uh, column has 4 values. So the output will be 4 comma 3. 4 comma 3. Now let me use LOC. As part of LOC, you can use, you know, since it is a two-dimensional object, you have to specify 2 values. One is for rows. After rows, you have to specify comma. Next to comma, you have to specify for columns. Okay. 0 comma A colon B. Or we'll do one thing. Let me discuss this topic tomorrow. We'll continue this LOC and ILOC tomorrow. Then we'll start a new topic. Okay? Right. It's time for your questions. If you have any kind of technical questions, please, shoot your questions, guys. If you don't have any kind of questions, I request data frame using nested list. See, when you are trying to create a dictionary using, when you are trying to create a data frame using dictionary, by default, a dictionary has key values, right? So the keys will be the column names, okay, and the values will be the values inside the rows, okay. So the same thing does not happen with series. That's the difference. It's better if you go and watch the video or the session again. Only for dictionary, the keys becomes the column names as part of data frame. Okay, and when you are trying to use a list, by default it will give you the list as is, right? But with respect to nested list, it takes as a row. One list inside a nested list will be a row inside a data frame, then the second one, then the third, then the fourth, so on. Can we append? Yes, it's possible. We can append data. So we have merge, we have concatenate. There are multiple functions, and when you go through the documentations of these functions, you'll understand what exactly the syntax is and what are the parameters. How can you play with the parameters of the values? Everything you can understand when you go through the documentations of the functions. Okay, so whenever you are having good time, spend going through the documentations of these functions. Right. Yep. If no questions, guys, we are conducting these sessions for the beneficial of the students, right? So everyone have to learn, and AI is in booming now, and it is grabbing the attention, right? So everyone have to learn Python, everyone have to learn AI. So I request all of you to share across multiple channels wherever there is a scope. If you feel these sessions are amazing, just hit on the thumb button, and please share your valuable feedback in the chat that we have, the link that we have provided. Even you can comment and share it across multiple groups, guys. Right, we'll connect tomorrow. Have a great day. Thank you so much. Signing off.